Okay, so in question 1623, form a quadratic equation with the given roots. So once again, remember what I said earlier, z squared minus sum of roots times z plus product of roots, okay? So, it's 18. Okay, so it's going to have z squared minus bracket. You're going to add the roots together. So when you add the roots together, you're going to get minus 1 plus 5i, and you're going to get minus 1 minus 5i. Add them together, you get minus 2. The add together becomes 0, minus 2 times z, and then plus product of roots. Okay, so product of roots. So you're going to multiply them by each other. Minus 1 by minus 1 is 1. Minus 1 by minus 5i is plus 5i. Minus 5i. Minus 25i squared. It's going to be minus 25 times minus 1. Plus 25 equals 0. So it's going to be z squared plus 2z. Cancel, and plus 26 equals 0. Okay, so there's your equation there. Okay, so the next one is question 19. And in question 19, what we can see is the plus or minus 3i. So we know that one root is 3i and the other one root is minus 3i. So z squared plus the sum of the roots. When you add 3i and minus 3i together, you get 0. Okay, so 0i, 0z, plus the product being 3i multiplied by minus 3i. And that gets you minus 9i squared, which in turn is plus 9 because I squared is minus 1. And then your formula is going to be z squared plus 9 equals 0. Okay, so that's quite handy. Now, next one after that, we got 21. Number 21, which is 2 plus 5 root 5i and 2 minus root 5i. So z squared minus the sum. So once again, the sum, guys, is going to be them added together. So 5i is cancelled. So it's going to be 2 plus 2, which is 4 for z. Because when you add 2 plus 5, root 5i to plus 2 minus root 5i, the root 5 is cancelled there. Okay, and then we're going to have to multiply them by each other in a second. So just track this. The 2 plus, we got to multiply them 2 plus root 5i by 2 minus root 5i to get the product of the roots. So we're going to get 4 minus 2 root 5i plus 2 root 5i. They cancel anyway. And then it's going to be root 5i multiplied by root 5i is going to give me minus 5i squared. And minus 5i squared is going to be plus 5. 4 plus 5 is 9. Z squared minus 4z plus 9. Okay, so that's 21 done. What about 23? And 23 is going to be minus a third plus 2/3 I. And then we're going to have minus a third minus 2/3 I. So z squared plus the sum of the roots. So it's going to be z squared plus sum. Add them together, the 2 over 3i's cancel, and we're going to get minus 2 over 3. Because minus a third plus minus a third is minus 2/3. Now we've got to get the product. So remember what the product means, you got to multiply them by each other. So we're going to get a 9th plus 2/9 I. 9th, 2/9 I. Then we're going to get another minus 2/9 I. And then we're going to have 2/3 by minus 2/3, which is going to be minus 4 over 9i squared. And then I squared is minus 1, so that's going to be plus 4 over 9. 2 down cancel. It's going to be plus 5 over 9. Z squared plus 2 over 3 Z plus 5 over 9 equals 0. So you're going to get 9z squared. Then 3 multiplied by 2z is 6z plus 5 equals 0. Okay, now we're on 25. Minus 3i is the root of this, x squared plus mx plus n, where mn elements are. Find the value of m and n. So, it says m and n are real numbers. This means that these aren't complex coefficients, they're real numbers. Okay, so that means that the conjugate has to be the other root. So it's got to be minus 3 plus 3i. And now we can do the formula here, z squared minus sum of the roots. So minus the sum of the roots is going to be adding them together, so it's going to be minus 6, the 3i's cancel, so it's going to be minus 6z. Then plus the product, so we're going to multiply them by each other. And when we multiply them by each other, we're going to get 9, and then we're going to get plus 9i, then we're going to get minus 9i, and then we're going to get minus 9i squared. 2 9's cancel, leaving us 18 here. And then we're going to get z squared plus 6z plus 18 equals 0. And now we know that it's a very similar equation. These could be x's for all we know, so it's 6x plus 18. So we know is that mx equals 6x, n therefore is 6, because the mx is in the 6x's position and the n is in the 18's position, so n equals 18. Okay, so this next one, now what it says is this is a quadratic, has 1, a equals 1, b equals 2, c equals k. It then states that k is a real number. So this means that all these are real. This means that the conjugate is the other root. Okay, and then we can do x squared minus sum of roots times x plus product to find the answer. Okay, 0. So what we can do here is we can say the sum is 5i, cancel with the other 5i, and what we get there is x squared minus 2 times x, and then plus product. So plus the product. The product's going to be minus 1 times minus 1 is plus 1. Minus 1 times 5i is minus 5i, and then we have a plus 5i. And then we're going to have 5i times plus 5i is minus 25i squared. Remember, I squared is minus 1, so it makes it a plus 25. 2 then cancel. You get 1 plus 25, that equals 26. And then you're going to have x squared plus 2x plus 26 equals 0. This means that this letter here is actually 26. Okay, now we're on to number 28. Now, what 28 wants us to do is it wants us to first of all do the multiplying the top and bottom, but the conjugate, because it wants it in this answer here. Okay, so we're going to have 19 minus 4i divided by 3 minus 2i multiplied by 3 plus 2i and 3 plus 2i again. And we're going to multiply them all by each other. We're going to get 57 38i minus 12i minus 8i squared, all divided by 3 multiplied by 3 is 9, and then plus 6i minus 6i, then minus 2i by plus 2i is minus 4i squared. Minus 4 times minus 1 being plus 4. Then they cancel. end, what we're going to get is this 8i squared is going to end up to be plus 8i squared. Oh, sorry, plus 8, excuse me. And then it's going to be 65 minus, plus 26i all over 13, which is 5 plus 2i, because 13 into 65 goes 5 times, and 26 divided by 13 goes twice. So we have 5 plus 2i there. Okay, it's 5 plus 2i. Now verify that z squared minus 10z plus 29 equals 0. Okay, so there's a couple of ways of doing this, I suppose. Okay, so the first thing you could say is you could solve it using a equals 1, b equals minus 10, c equals 29, and if the roots turn out to be z, which is 5 plus 2i and 5 minus 2i, then you've proven that this does equal 0. Another way of doing it would be just to input the value in. So for example, replace anywhere you see z, replace it with 5 plus 2i. So 5 plus 2i squared minus 10 times 5 plus 2i plus 29 equals 0. And then we multiply this out, 5 plus 2i, 5 plus 2i, multiply that out, you get 25 plus 10i plus 10i plus 4i squared, then minus 50 minus 20i plus 29 equals 0. And then we're going to get this is a minus 4, so it's going to be 25 minus 4 is 21. 21 plus 20i, this 20i here, but it cancels with the minus 20i over the other side. And then we're going to get 21, and what's left is 21 minus 50 plus 29. And then what we can see is 0 equals 0, and hence this is verified. Hence find two complex numbers u such that u plus 3i minus 10u plus 3i plus 29 equals 0. Okay, so I haven't seen a question like this before, but what I'm going to do is I'm just going to multiply them out, okay, and see what happens. So I'm going to get u plus 3i times u plus 3i, then I'm going to get minus 10u. U is like z or x in my opinion, okay, because we want to find u equals a complex number and u equals another complex number. Number is plural, there should be two answers, okay, so it's going to be 10u minus 30i plus 29. And then you're going to multiply it out again, you're going to get u squared plus 3ui, then plus another 3ui, and then plus 9i squared, and plus 9i squared is the same thing as minus 9. And then we have minus 10u minus 30i plus 29 equals 0. Now let's group this into a quadratic equation. We got 1u squared. Then the second one, I think we got 6ui minus 30i, and this 6ui minus 30i is the it's minus 6u or 6iu. Okay, so it's a complex number, anything with u in it, because remember quadratic equations go u squared u number or x squared something, and then something times x times the number, so it's going to be u squared and u that what we need to put together. So what I'm putting together is the u's, and there's a 10u there as well, so it's different this time around, so we have to do the u's. U, this one doesn't count, u. So it's going to be 6ui minus 10u, and then at the end it's going to be minus 9 plus 29 is plus 20, so it's going to be minus 30i, we'll do it this way, plus 20 minus 30i. Then we got to group it, so we got u squared plus 6i minus 10 times u plus 20 minus 30i times 0. So we can see here is that a equals 1, b equals 6i minus 10, so therefore minus b is going to be 10 minus 6i, and then we can see that c is 20 minus 30i, and then we're going to put it into the minus b formula, find out what u is. So it's going to be 10 minus 6i plus or minus b squared. Now, what is b squared? B squared is 6i minus 10, 6i minus 10, 36i squared, minus 60i, minus 60i, plus 100. 36i squared, minus 120i, plus 100. Now this 36i squared is minus 36, and minus 36 from 100 is 64, so we're going to have 64 minus 120i. That's the b squared part. Now we're on the minus 4ac part. Minus 4ac, so it's got minus 4 times 1 is 4, 20 minus 30i, and what we're going to get is minus 80 plus 120i. That's good news because those 120i's cancel, and that's all over 2. And then we're finally going to have u equals 10 minus 6i plus or minus the square root of minus 16 all over 2. Remember, minus 16i, root minus 16 is the same thing as 4i. So what we're going to have is u equals 10 minus 6i plus or minus 4i all over 2. Then u is going to equal either 10, so minus 6 plus 4 is minus 2i over 2. And then the other one, u, is going to be 10 minus 10i, because minus 6 minus 4i is minus 10i over 2. Then finally what you get is 5 minus I, or 5 minus 5i. So there's our two answers there. Okay, so that is 28. Okay, so find the value of this number that's a real number if this is a root of the equation. So if it's a root of the equation, it has to satisfy equal to 0. So replace all z's with 3 minus 2i. So 3 minus 2i squared plus 1 minus I multiplied by z, which is still 3 minus 2i. Then minus 6 plus pi I, or lambda I, as it's called. Multiply this out, 3 minus 2i, 3 minus 2i. So what we get there is 9 minus 6i minus another 6i plus 4i squared. 4i squared is minus 4. Then keep going, then you get 3 minus 2i. Then you have minus 3i plus 2i squared. And then you get minus 6 plus pi I. Now all the i's have to be equal to 0, because over this side is 0 plus 0i. So let's concentrate in on the i's. So you have 6i, that's minus 12i. You have another minus 5i here. And then you have plus pi I, or lambda I, equals 0. So it's going to be minus 17i plus lambda I equals 0. This means that lambda I, the i's can cancel, bring the 17 over the other side, lambda has to equal to 17. Okay, so then finally the last question, question 32. Solve this equation. Write your answers in the form a plus bi, where a, b is element q. Remember, element q means whole numbers, positive or negative. Okay, So it's a very simple question. Even if you didn't understand that part, you just got to solve the quadratic equation. So a equals 2i, b equals 6 plus 2i, so minus b equals minus 6 minus 2i, and then c equals 3 minus 6i. Do the minus b formula, so we have minus 6 minus 2i plus or minus the square root of 4b squared. Now b squared is going to be 6 plus 2i by 6 plus 2i. We're going to get 36 plus 12i, which is plus 24i, and then plus 4i squared at the end. It's going to be a minus 4, so we're going to get 32 plus 24i. And then, once we've done that, what we're going to do next is multiply minus 4ac, so it's going to be minus 4 times 2i times 3 minus 6i, that's minus 4ac, so minus 8i times 3 minus 6i, minus 24i plus 48i squared, minus 48 minus 24i, minus 48 minus 24i, then they cancel, so that's going to be over 2i. Then we're going to get minus 6 minus 2i plus or minus, now this is going to be the square root of minus 16. Square root of minus 16, we've done it enough already, it's 4i. So plus or minus 4i, once again for those of you who don't remember, root 16 by root minus 1 is 4, square root of minus 1 is defined as I. Okay, then once we've done that, what we're going to do is all over 2i. It's going to be minus 6 minus 2i minus 4i all over 2i, and then it's going to be minus 6 minus 6 minus 2i plus 4i all over 2i. Now this is an interesting question, because what's happened here is we're going to get minus 6 minus 6i all over 2i, and then the other one's going to be minus 6 plus 2i all over 2i. Now we're not allowed to have a complex number on the bottom, so I'm going to write this as 0 plus 2i, and this one's going to be 0 plus 2i as well. We got to multiply top and bottom by the conjugate. Okay, if you remember correctly, for getting rid of complex numbers on the bottom. So there's just an extra bit in at the end that makes this question reasonably difficult. So minus 6 times that is minus 12i. Then that's going to be plus 12i squared. 12i squared being minus 12. And then on the bottom we're going to have 2i times minus 2i is minus 4i squared. Minus 4i squared, same thing as number 4. And then we're going to have minus 3i. Minus 3 minus 3i for this one here. Then the same thing here, we're going to get a plus 12i. Oh sorry, excuse me. It's a plus 12i. So it's plus 3i, excuse me. So minus 6 by minus 2 is plus 12i. That's going to be minus 4i squared, which is plus 4. And we've already done the bottom part here, it's over 4. And this one's going to be 1 plus 3i. Okay. Excuse me there, and there's just one little mistake there at the end. Okay, so what it was meant to be here, see the way it's 2a and a is 2i, so it's meant to be 2 times 2i. So this here is meant to be 4i. That's meant to be 4i. This here is also meant to be 4i. And this here was meant to be 4i. And what that did was that's going to change the conjugate. Okay, so the conjugate here was wrong. Excuse me guys, it's a quick mistake on that. So that was 4i. And this one here was minus 4i. And that's a 4i there, 4i there, so 1 minus 4i over 4i there. So we'll just rub out this part here and let's see what happens when we fix this up. So what we're going to get is, on the bottom we're going to get so minus, it's going to be 24i. 6i times that is 24i squared. 24i squared is the same thing as minus 24. This here is going to be 4i multiplied by minus 4i, which is minus 16i squared, which is 16. And then 24 divided by 16, it's going to be 3 over 2. Minus 3 over 2, because minus 24 over 16 is minus 3 over 2. 24i over 16 is plus 3 over 2i. Now that explains the q part. Q. Okay, so it's 3 over 2i minus 3 over 2 plus 3 over 2i. Okay, and then the next one is going to be plus 24i minus 8i squared. Minus 8i squared is plus 8. And once again, we're going to divide all that by 16, and then we're going to get a half plus 3 over 2i. Okay.